Cool. Good morning, everybody, and welcome to this Advanced Lightning Components session. My name is Christoph Conrads. I'm a developer evangelist with Salesforce, and this is my Twitter handle. So this session is really about advanced Lightning Component techniques. So I want to know a little bit about you before we start. So how many of you have actually written Lightning Components? Yoo-hoo, that's exactly what I wanted to see. Now, I need to show you this slide, which makes me extremely uncomfortable as a developer, because that is really not my voice. I feel uncomfortable. So I thought about it, and I thought, okay, this is an advanced Lightning Component session, so maybe I can get some help. So here's what I try to do. We'll see if it actually works. So this is my home page. I'm going to go straight in App Builder. And you saw that there was the assistant there. So I'm going to see if I can find another component. Oh, look here. There is a component called text-to-speech that I'm going to put here. And then I'm going to do that and go back. And now this is my forward-looking assistant. It's right there, right? So I'm going to see if it works.
You should make your purchasing decisions based on currently available features and not forward-looking statements made in this presentation.
There you go. So I don't have to do it myself. Thank you. It's really super convenient. But it's actually really related to the talk that I'm doing here, because as you can see, this is a Lightning component. So let's take a quick look at that Lightning component. It's actually behind the scenes using the Chrome speech APIs. And the problem is that there is something called the locker service in Lightning Components. Have you heard of that before? And it kind of prevents you from using some APIs that may or may not be secure or safe. And what I wanted to show you is that when that happens, maybe you face a framework that you cannot use because of the locker service. You always have a way to use these frameworks, and that way is called the Lightning Container Component. It's right here. Okay, and so what you do is it's kind of a little container that provides a safe sandbox, and everybody feels good that it's going to be safe. It's not going to do harm to your application. You point to a static resource, and then it's going to load that thing. And that thing could be anything. It could be a React application. It could be an Angular application. It could be some framework that you really have trouble using with the locker service. And as you can see, in this case, the UI is actually written with Lightning Components. And then there was that Say button. And can you read this? Yeah. So it says, OK, when we click that button, we actually execute the Say button clicked. And so we have a little protocol, a little API that's going to communicate with that JavaScript application, right, by sending a message. That's what you're seeing here. So again, this could be any type of JavaScript application written with any framework, and you can communicate with it using that message API. So in this case, that application is actually super easy. Here's the code. So as I mentioned to you, it's actually using the speech API in Google Chrome to simply say what I passed as a parameter to my message argument. That's all. And so this is a simple use case, but people ask us all the time, can I use React? Can I use Angular? Can I use library XYZ? The answer is yes. You use the Lightning Container Component. So with that, we can now go back to this slide. It's done. Great. And look at the agenda. So we are already done with the first item. We spoke about the Lightning Container Component. So what we will do in this presentation, we will cover advanced techniques to do data access, data binding, to write modular code, and to work with events. So without waiting, let's start with the first topic, which is data access. Oftentimes, people come to me and ask me, my application is not performing well. Do you have advanced techniques, maybe DOM renderings, really sophisticated stuff? And my answer is always first check data access, because most of the time, that is really the bottleneck in Lightning applications. So what I want to do is to look at some examples of that. So we'll start with the first application that some of you may have seen. This is a mutual fund explorer, so a financial services application. This is a list of mutual funds, and when you, so investments, right, if you're not familiar with that. And so when you mouse over, it gives you, the return year over year and that kind of stuff. And then I can, navigate because I have a lot of them, and then I can come back and do all sorts of things. Now, I wanted to take a look at the log here, because I actually log the time it takes every time I go to the next page. Can you read this, or I will zoom it a little bit? Okay, so you see that I log the time it takes to actually make a call to the server to actually get that next page, that next kind of, page of mutual funds. And you see that roughly it takes about 200 milliseconds to make that call. And you notice that I click next page, 200 milliseconds. And then I click previous page, 200 milliseconds. But that's kind of silly, isn't it? Because I just had that page before. And it kind of, the way my application is written right now, it doesn't matter that I had that page a second ago. I'm going to go back to the server and waste 200 milliseconds. Now, you may say, what is 200 milliseconds? But that's just one component on the page. You may have 10 or 20 of them. And when you add up all these 200 milliseconds, that starts to count. Okay? So what we're going to try to do here is fix that problem, right? And to fix that problem, I'm going to use a feature of the framework called storable actions. Okay, and the way it works, it's actually super easy. It's probably the easiest thing you can do to dramatically improve the performance of your application. So here is where it happens, right? This is the code that you've seen many times before to invoke an Aura method, an Apex method, and bring back data, right? So it's an action, and here, this is really the name of the method in Apex that you want to invoke. Okay, so what I'm going to do here, I'm going to add one line of code, and that is action set storable. Okay, you see that's one line of code. Then I'm going to save this, and I'm going to go back here. So what I'm going to do, I'm going to clear the console, and we're going to reload this page. Okay. So as you can see, again, it took here 218 milliseconds. Okay, so that's expected. We need to get the first page for sure. And then the next page, 266. Okay, 270, that's consistent. But look what happens now when I go back to the previous page, right? I'm going to go back to the previous page and look at this. That is not even a millisecond. 0.9 millisecond, because that page I now have in cache. Okay, and so I'm going to go back to page 1. I have it in cache, 0.8. So page 2, have it in cache, super fast, super fast. Now I go to page 4, which I don't have in cache, 168. Okay, now this works for anything. Like for instance, I'm going to filter by sector, let's say agriculture. Okay, so now I didn't have that specific filtered data set. So again, it took 171 milliseconds. But I'm going to go back here to all. And of course, that data set I already have, so 1 millisecond. I go back to agriculture. Now I have it in cache, 0.8 milliseconds. Okay? And what did I do? I added one line of code to my application. This can make a dramatic difference on performance, so keep that in mind. So basically what this is using, it's using a client-side cache, right? So I'm storing the data in a client-side cache. So let's go back to to the slides for 1 second here, and there are really two numbers that you need to be aware of when you work with set storable. One is called the refresh age, and the value is set to 30 seconds. And the other one is called the expiration age, and its value is set to 900 seconds, which is 15 minutes. All right, so how does it work? When you make a call to the server, if we have the same, if we made that call before and we have the data in the cache and it has been in the cache for less than 30 seconds, we will give you that value. We will not go back to the server. Okay, so everything that's left of 30 seconds, if you want, has been in the cache for less than 30 seconds. We will consider that fresh data and we'll give it to you without going back to the server. Everything that's older than 900 seconds, has been in the cache for longer than 900 seconds, we will consider that expired. We will not even look at that. And then everything in between, let's say, for instance, 45 seconds. Suppose you ask for a data set that we have in the cache, but it has been there for 45 seconds. We'll say, maybe that's still OK. Maybe the data is still the same. So I'll give it back to you right away, back to that component that made the call. But behind the scenes, the framework is going to be smart and go back to the server to double check. And then if the data change, then we'll provide that new value to the component. So let's take 3 examples here. So in the first example, my component is making a call to the server for data that we don't have in the cache or data that has been expired. Okay? So you, the developer of that component, you make a call. You think you're making a call to the server, but of course that call goes through the framework. And the framework tries to be smart all the time, right? So the framework is going to ask its client cache, hey, do you have that data set that I'm being asked here? Do you have that in the cache? And in this first example, the client cache is going to say, no, I don't have it. So then the framework is going to do what you expect. It's going to go to the server, make the request. You're going to get the response. It's then going to set that value in the cache and return the value to your component. Okay, so that's traditional workflow. But the benefits come here with this second example. The same component or another component makes a call for the same data, right? So the framework, again, tries to be smart, asks the cache, do you have that data set in cache? And in this case, the cache has it. It has been there for less than the refresh age, so less than 30 seconds. So the framework is going to say, yes, I have it, here you go. So you think you're getting the data from the server, but you're really getting the data from the cache. And in this example, the server is not involved at all. You never go to the server. So that is a huge win in terms of performance, right? And here is the third example, the one that's a little more tricky. So in this example, the data is available in the cache, but is older than the refresh age. Remember, the refresh age is 30 seconds. Maybe the data has been in the cache for 45 seconds. Okay, so what happens in that case? So the component makes the request, the framework tries to be smart, asks the cache says, yeah, I have it, but it's kind of a little old. The framework says, well, let's be optimistic here and assume that it's still okay. So I'm giving you that response right away. So your application, your component is super responsive. But the framework is like, but I really wonder if the data is still fresh. So behind the scenes, the framework is making a call to the server, gets a response, set it in the cache, and then says, okay, but is this response, number 6 here, is it the same value as number 4, the response that I already sent to the component? If that's the case, that's it. Nothing else happens. But if it's not the case, in other words, if the data changed, then the framework is going to call your callback method a second time. So this is weird at first. You have to realize that when you use set storable, your callback method in your component can actually be called twice. Now, if you use Facebook, which I'm assuming a lot of you use, you have seen that kind of, paradigm where you load your feed, boom, you have immediate data. And then, maybe a second later or half a second later, poof, it refreshes, right? That is the exact same kind of metaphor, right? We give you data as soon as possible so you don't wait, but we check behind the scenes and give you updates if there are updates, okay? So that is storable actions. And the key idea here is that we try to avoid round trips to the server because those are super costly. Now, there is a second principle. So the first one is go to the server only when really needed, and storable actions can be super helpful for that. Okay, so let me show you a second example that I want to discuss with you. This is using the Dreamhouse application. And how many people know Dreamhouse, have seen Dreamhouse? A number of you, that's great. So Dreamhouse is a sample application for the real estate business. It really doesn't matter. It's just a sample application that shows you how to build applications on the Salesforce platform. And the first time when I built Dreamhouse, that was about, I think, 2 years ago. And the way I build it, so you have all these components here. So, it's basically the property record page, right? So you have the details about a property, but I wrote a bunch of custom components. Like, for instance, that path is actually a custom path. Then it shows you with a nice bar chart here the number of days that property has been on the market. It locates the property on a map, and it shows you nice pictures of that property. That's great. But if you think about it, this is cool. This is application composition. You create a page by assembling components. The problem is that all of these components need the record data, right? So to be able to show how many days the property has been on the market, I need access to the record data, okay? To be able to give you the location of the property on a map, I need access to the record data. So the first time I wrote it, every single component was making a call to an Aura method, to an Apex method, right? So now think about it. How many components do I have? 1, 2, 3 in the sidebar, 4. So that's 4 custom components, plus probably that is, a default component, and maybe the header is 1, 2. So that's 6 components on that page. Can you imagine the performance impact if 6 components go to the server to get what? The exact same record. All these 6 components are going to call the server to actually get the exact same record. So that's pretty bad in terms of performance, right? So a year later, so I don't know, it's probably about a year ago, we introduced the Lightning Data Service that went GA, is it now in winter 18, I think? I lose track. So it went officially GA in winter 18. And the Lightning Data Service avoids that problem. And the good news, very much like with storable actions, is that you don't have to worry about it. All that logic to share the record data between components is part of the framework. So let's take a quick look at the code here. So you have, for instance, property path. So that was that path component on top. So this is the Lightning Data Service, right? You specify the fields that you want, okay? And then, in this case, it's in edit mode. No, something that you want to notice here is that if you look at the component itself, notice that there is no controller. Right? There is no Apex controller. You are never going to make, you don't even need to write Apex. You are never going to write any Apex. And to save the new value, if I click a new step on the path, the only thing that I need to do here is save record. So find a reference to that data service and do save record. And everything happens automatically. There is absolutely no Apex code to write. But there is one additional benefit that is super important. Have you ever seen applications built with components that show similar data, but they are not in sync. So, one value shows, maybe the price here, $500,000, and then the price in another component for the same property is different because you modified the data in the first component, but the second component didn't sync. Okay, so the second benefit of Lightning Data Service is that if I change the value here, you see pre-market here, and we can see it here in the default layout as well, right? So if I do this, if I say, okay, now it's available, notice that immediately that value is synced here, right? If I change, so it has been 47 days on the market, but imagine that in fact maybe I made a mistake and it was not listed in September but in October. As I save, boom, the days on the market reflects that new value. And that happens automatically. You don't need to send application events around. That all happens automatically. If you were in the keynote yesterday, maybe you remember this example, right? So this is also using the Lightning Data Service. So I have two components here. In this component on the right, I can change the irrigation of a field. These are allow fields, or here I harvest pumpkins. Doesn't matter. But look, here I'm going to change the irrigation. You see that on the right, this thing, the little icon shows the new status of that field. There is no application event that is sent around. They are both connected to the same record using the Lightning Data Service, and that synchronization happens for free when you use the Lightning Data Service. Okay, so the benefits, no apex to write, and automatic synchronization between components. So how does it really work behind the scenes? So let's take a look at an example on the slide here. So you have three components. Let's say that the first one is going to ask the Lightning Data Service, remember the fields that we request on the force record data attribute? So the first time the Lightning Data Service doesn't have that record, so I'm going to the server and I load the two fields that you asked me, so the name of the property and the status, and I always load the ID so that I can identify the record. Now, the second component is going to need the same, let's say, is going to need the same fields. At that point, the Lightning Data Service works as a cache. It's going to give you these values without any trip to the server, right? So, and you have nothing to do. Now, the third one also needs record data, but slightly different fields. Maybe I still need the name, but in this case, that looks like it may be the map, okay? I need another field. I need the location of that component, okay? So in that case, the Lightning Data Service is going to say, okay, I already have most of the fields, but I'm going to go back to the server just to fetch that additional field. Okay, so it's super efficient in the way it's fetching records and fetching different fields on the record to give you exactly what you want, but in a very economical way if you want. And again, this is automatic cache that you don't have to manage yourself. All right, so let's keep going. So data binding. I'm assuming you're all familiar with this notation, right? So curly braces, exclamation mark, right? So this is how you bind inside a UI element. You're going to bind some values, in this case of the contact attribute. This is called bond expressions, and bond expressions is another way of saying bidirectional data binding or two-way data binding. And this is super cool. Super easy to write, okay, to keep your UI in sync with the data, but it's also very expensive. Did you know that in order to implement that, for each bond expression, and look, we are in a loop here, we are in an array, this is an iteration. For each bond expression, we actually have to set two event listeners. So it works like this behind the scenes, and that is simplified pseudocode. But basically, we need to send a first event listener that says that if the model, if the attribute, if the contact changes, I have an event listener to update the UI element, which in this case is an input field. Okay, so that's the first event listener. And then the second event listener is the opposite. If the user changes the value in the input element, then I have an event listener, a change event listener, that's going to update the model, so the attribute, accordingly. Okay, so for each bound expressions, I'm going to have to do that. Now, look, again, I'm going to go back to my slide. This is in an iteration. I may have a ton of bound expressions here. So convenient, but expensive. So in a recent release, we introduced unbound expressions. Very similar syntax, but instead of curly exclamation mark, it is curly hashtag. And that is called unbound expression. Why unbound? Because once we set the value, we completely decouple these two things. The model from the UI element. We set the value, and then that's it. They don't know about each other anymore. The biggest misconception about unbound expressions is that a lot of people think that this is one-way data binding. So that, in other words, that the UI element is still bound to the model. And if the model changes, the UI element is going to change. That is not the case. This is actually one-time data binding. In other words, I set the value, and after that, there is no synchronization because we don't set any change listeners at all. The benefit, no change listeners, so super cheap, super fast. The downside is that if you want to keep things in sync, that's probably not what you want. So let's take an example. Let's take another example in Dreamhouse. So this is the Property Explorer. So you have a list of properties, and then you can select a property, and on the right you see data for the selected property. Okay, so that's pretty cool. So let's take a look at the way this is implemented. So let's move here. Okay, we should have property tile list. Here we go. So that's that component. Okay, so we have that iteration here to show, all the properties, and then we have property tile here. You know what? I want to make it unbound to save event listeners. So instead of the exclamation mark, I'm going to do hashtag. And then inside, you see that I'm using property tile here, right? So let's take a look at property tile. Look, it's full of curly braces, exclamation mark. So let me change at least a few in the interest of time to curly braces hashtags. And I'm going to save that again. And we're going to see if it works. And the good news is that it works, right? And why does it work? Because by definition, if you are inside an iteration, when a tile is created, it's because we have a property record. So we set the values, and we can display it. Now let's try something else. Look, you see that property summary here? I'm going to click that, and I see I see the details on the right. Okay, so that's in a property summary component. Okay, it's right here. Okay, so again, here I have all the bound expressions to display the details of that property. I'm going to change that to unbound expression, again, to try to improve performance. I save that. I do it only for the address and the city in the interest of time. I refresh, and I select, oh, look, my address and city is gone. It's not working. Any idea why? So remember, let's refresh that again. So at this point, the component is created. Okay, it is created. What is the value of the property attribute in that component at this point? Nothing, because I didn't select a property in the list there, so it's undefined. But unbound expressions, they doesn't care. I'm saying, oh, it's undefined, so I'm going to bind to undefined. And then remember, it's one time. So after that, there is no listener anymore. So when I change the value here, that address and city at this point is totally unbound, so it doesn't work. Okay, because it's not listening for changes anymore. It's already bound to undefined. Okay, so in this case, because I want to sync between the list and the details, I need to bind, and I need to use bound expressions. But when you work with arrays, and that's really where you can save a lot of resources, oftentimes unbound expressions work really well, because again, by definition, you create the records when you actually have the data. Does that make sense? So the golden rule here is whenever you can use unbound expressions, you're going to save a lot of resources. Okay, so now we're going to talk about writing modular code. That is a question that people ask a lot. They're like, we have JavaScript code, and we want to use it across multiple components. And we can't find an easy way to do that with the Lightning Component framework. So if you use the latest version of JavaScript, like ECMAScript 6 or 7, right, there is that new thing called JavaScript modules. The problem is not all browsers support JavaScript modules yet, so we don't support it in Lightning Components yet. But before JavaScript modules really existed, the JavaScript community had already come up with ways to do the same thing. So let me show you an example here that I want you to think about. So this is a kind of a dashboard showing Olympic medals. It doesn't matter. What matters is this is using a third-party library called Chart.js to build these super cool animation and all that, right? Anybody knows how to use a JavaScript library in the Lightning Component framework? How do you do that? Well, there is a tag for that. Anybody? Require, LTNG require. And with that, you can use a third-party library. So think about it. Nothing says that that third-party library that you're going to use with LTNG require cannot be built by you. All right, so you use Chart.js, you use other libraries. You can also build your own and also use it with LTNG require. Okay? And so that is how you can build reusable JavaScript libraries that you use across multiple Lightning components. Let me show you an example. So we're going to go in the code here. The simplest way to write a library is as a static resource, right? So I have a static resource, which is actually a JavaScript file. And so I basically declare my library. I attach it to the window object, and I call it counter. Okay? And it has a value initialized to 0, and then it has two methods, increment, I will increment that value, and get value. Okay? And then I'm going to show you a component, a Lightning component where I actually use that library. So you see this here? So this is my counter library. This is now the third-party library. This is the library that we just looked at. Okay? And then I have a button that says get value, increment, and how is that implemented? Simply by invoking the get value method of the counter object or the increment method of the counter object. So let's see that in action. So I'm going to go here in demos, and we're going to go in App Builder, and I'm going to look for that counter component. Just for fun, I'm actually going to paste two of them. Okay? And I'm going to save this and go back. Okay? And so get value 0, remember, and then I can increment that. Right? And so here, I will share the same code in that second instance, But the thing that you need to be aware of is that, in fact, you are also sharing the same values. So if you increment there, it's kind of a shared library if you want, right? So you are incrementing the value in both. So you can also, so this would be a great way to implement a completely custom cache, by the way, okay? So by sharing that value. You could also change the code a little bit to use a constructor. So let me show you quickly a second implementation of that same thing, so of the same counter here, okay? But in this case, counter is defined as a constructor, meaning that every single library that is going to use this version of the counter library is going to create a new instance with new, and in that case, it's going to have its own version of the value, and you are not stepping on each other. And it's really up to the use case that you're using, which one is the best. So that is one way to write modular code, to write JavaScript libraries. There is another way that I quickly wanted to discuss with you, and that's to create what we call service components. A service component is a Lightning component that has no UI at all. Okay, so let me show you an example of that. I have an account data service here. Okay, you see it there? Okay, let's open that. So when I open it here, the first thing you notice is that there is really no UI. However, it declares an Aura method, and that's essentially declaring a public API, okay, that other components can invoke, right? So you're creating a UI-less component with a public API, and in this case, the account data service has a public API with one method called findAll. So what happens when another component will call findAll? Business as usual. You are invoking a method in an Apex controller. Okay? So what's the benefit of declaring a component that has no UI? Well, the benefit is, of course, that you can use it in other components. So I have a component here called account list. So let's open it. And notice how I actually use the account data service here. I just embed it in my component, right? Notice, by the way, that account list doesn't have a controller, which is great because a lot of times people ask me too, can a Lightning component have multiple controllers, maybe an account controller and a contact controller? And the answer to that is no. You can't. A Lightning component can only have one controller. But with this approach, you can actually access data from different objects, right? Because I can embed account data service, contact data service, whatever. Okay? And remember that account data service has a public API. Remember the name of that public API? findAll. Thank you. So on init here, what do I do? Because I want to retrieve that list of accounts right away. So I get a reference to that service component, and I invoke findAll. And when I get the data back, I set the data attribute of my component so that I can display the list of accounts. Okay, so now you have really encapsulated your data access logic for account in a completely reusable component called account data service that you can embed in any other Lightning component. Let's see if it works. So I'm going to go back here to my demos, edit page, and we are going to bring that account list component right here. And you see that even in App Builder, you can already see the data. Okay. And remember, account list doesn't even have the account controller. The data access logic is entirely reusable, encapsulated in that account data service component. Okay, so two ways to write reusable code. JavaScript libraries and service components, okay? And I will finish, so we covered this. I will finish with events, simply to show you what not to do with events that we have seen that costs a lot of resources. And I will ask audience participation. If you have an embedded component, component B embedded in component A, what type of event do you use if component B was to communicate back with component A? A component event. What type of event shouldn't you use? An application event, because that's extremely costly, and that's also the source of confusion, because when you fire an application event, all the other components on the page can actually listen to it and handle it, right? Here you want private communication between component B and component A, component event. If two components are completely unrelated in the DOM hierarchy, that's typically the app builder use case. What type of event do you use? Application event. If you find yourself using application events outside app builder, please think twice, because you may be doing something wrong that is actually very costly. And now, super exciting, there is a new type of event. If two systems, two completely different applications, one can be Salesforce and one can be something else, need to communicate through events, what type of event do you use? Platform events, exactly. And that covers all the family of events. And that is what we wanted to cover. So remember, cache, cache, cache with storable action, Lightning Data Service. Use unbound expressions when you can. Write reusable code with JavaScript libraries or data service components, and use the right event type. And that's really all the time we have. So thank you very much. Thank you.